Go over what collections are. So to begin with, collections initially are a way to be able to hold stuff. Um, the difference between a collection and an array is that an array is given to you by the programming language initially, and you can call it a primitive. So imagine if we had an analogy of, say, the gods have given us things in our nature, in our world, and those things are primitive things. And then we as humans have created certain things with those primitive things that are now called man-made. So a collection would be man-made, and an array would be a primitive. So a collection usually adds certain functionality that you can expect. All collections should have add, remove, update, sort, search, and other methods. But how do they exactly work? So again, imagine that the gods have given you a container, and then whenever you need a container, which is a primitive type, you have to ask them, hey, I want an array and I want it of size 20. So then nature gives you back a container of exactly size 20. You can use 0 of that, or you can use up to 20 of that, but no more. But then what if we want to be able to use containers, but we don't know exactly how much we're going to need? Maybe we need more than 20. Maybe we need a million. Maybe we only need 10. We're not sure. So that's when man-made collections come into play. So you've got men who took that array, that primitive array, and then have added functionality to that. These machines, let's call them, are really functions or methods, and they are able to manipulate the array that's inside of the collection. Say we have X amount of stuff and we want to be able to store that. We tell our collection, start off with an array of 10. We're never going to get to see that array. From this collection, we're going to call the add method, and we're going to give that add method stuff. That add method is going to add it to the inside array. And at some point, the inside array is going to become full. So the collection needs to know what to do when the array becomes full. We shouldn't be the ones that had to deal with growing and sizing of the inside arrays and asking for more space or a bigger array and so on. So the add method says, okay, I've added 10 things and I know that this array can only hold 10 things, so I'm going to call this other, say, machine function called grow. And what the grow machine does is it goes back to nature and says, hey, I need another primitive array, but now I know that I have a size 10 one, I want twice as much space as that. So then nature gives it back an array of size 20. And when you have this new array, you also have your old array with all this stuff. This new array has nothing in it. So now we have to transfer everything. So what the grow method does is it's going to transfer the things from the old smaller array to the new bigger array. And that's all things that collection does on itself that we don't have to worry about because we're just calling add, and we continue to add stuff to it, and the collection itself is going to grow that array continuously, regardless of how many things we give it. So what kind of collections are there? We've got maps and lists, which is mostly what we're going to be dealing with in this class, more specifically hash maps and array lists. Array lists are called array lists because they use an array inside of it, and they have functionality that's expected of all lists, which we'll learn a little bit later. But the example that I just gave is technically an array list. And then a hash map, it has a key and a value, and uses a hash function to be able to know where to store things, but also uses an array inside. So technically it could be called an array hash map. It's up to the people who make them to name them. And we also have stacks and queues, which we're going to look at later in the year, and decks as well. What's the difference between them? Well, it really just depends on how the little machines or functions inside of the collection deal with the array internally and growing it and sizing it and storing stuff in it. You could say that some of them are ordered and some of them are not. Technically, they're all in some order. It just depends on whether you can use an index to be able to get that out. So with ArrayList, you can say, give me the thing at position 0, but with hash maps, you can't say, give me the thing at position 0. And we'll find out a little bit more why later. And they also have different ways of knowing where to put things within the internal array. But for the most part, we don't have to deal with that array, so we don't have to worry about that. So why do we use collections in general? Why can't we just use arrays ourselves and then we resize these arrays whenever we need to? Well, that's kind of cumbersome, and it also, we don't know best. So the people that created these collections, they know about best performance and how to size and resize, how to store things, and how to best create functions that deal with internal primitive storage. So it's better if we let them do that job, and we know exactly how and what we expect from the collections that we're getting. It also helps us write some clean code, and it makes things predictable because they all have specific methods that we know and we can expect. So we can store things pretty easily while not worrying about how to best, performance-wise, store each one of those things.